flow sensor is a device that used for measuring the flow rate or quantity of a moving fluid, gas or vapor that passes through them over a certain amount of time. It consists of a primary medium connection device, transducer and transmitter. Transducer senses the fluid that passes through the primary device, while transmitter produces an output signal from the raw transducer signal.
Applications of flow sensor: cooling systems, water treatment, industrial washing system, and irrigation.
Paddle wheel flow sensors. It is one of the most common types of flow sensor. The sensors are connected to a pipe with liquid passing through and turning a paddle wheel. The primary device calculates the speed as the paddle is turned.
Magnetic inductive sensor. This type of sensor detects three process categories: volumetric flow quantity, consumed quantity, and medium temperature.
Rotor flow or variable area flow sensors. Rotor flow meters are a tapered tube and a float. It is most widely used for gases and liquids flow measurement because of its low cost, simplicity, low pressure drop, and linear output.
Here is how the measurement method works. Inside the ultrasonic flow meter, pairs of sensors are filtered across from each other in a measuring tube. Each sensor can alternately transmit and receive an ultrasonic signal. Simultaneously, the transit time of this signal are measured. The ultrasonic signal are generated with P electric crystals applying a voltage. Conversely, a PIC electric crystal creates a voltage when an ultrasonic signal impacts the sensor. By increasing the number of sensor pairs, it is possible to accurately detect and mathematically compensate for flow profile distortions over the entire pipe cross-section. When there is no flow, the signal transmit time are the same upstream and downstream. Once the fluid starts to flow in the measuring tube, the ultrasonic signals are accelerated in the direction of the flow and decelerated against the flow. As a result, the ultrasonic signals now have different transit times, less time in the direction of flow and more time against the flow. Therefore, the differential transit time measured by the sensors is directly proportional to the flow velocity in the pipe, together with the known tube cross-section. The actual flow volume can then be calculated. The greater the flow velocity, the greater the measured fine difference between two ultrasonic signals.
For ultrasonic flow measurement, the sensors do not necessarily have to be fitted into the pipe wall. With the clap-on system, for example, the sensors are fastened directly onto the outside of the pipe. They can be retrofitted at any time without interrupting the process. With clap-on sensors, the ultrasonic signal is passed directly through the pipe wall and into the fluid. This signal continues through the fluid, is reflected on the upper side pipe wall, and are measured by the second sensors. In this example, with the two traverse insulation, the clap-on design is unique because flow rate can be measured in very large pipes up to 4 meters in diameter. This possibility increases the area of application, for example in the water at hydroelectric industries.